Hello, Keith Rucker here at VintageMachinery.org. Guys, today I'm over here at my Kearney Tracker Model 2D. This is my rotary head milling machine that I really have enjoyed using, and I'm starting to use a little bit more in the shop. Mainly because it's just a little bit heavier, beefier of a milling machine than my Wells Index or a Bridgeport type knee mill machine. So if you're doing a little bit heavier type work or just really want to hog some metal off, this machine is more capable of doing that than a Bridgeport type machine. I think the big advantage of the Bridgeport type machines is the quill in the head for doing drilling and stuff like that. But for just doing straight up milling, this machine right here just makes things a little bit easier to use in some situations. The downside to this milling machine has to do with the tool holders that go into it. Now, you know, with a Bridgeport type machine, my Wells Index is a good example. It has a spindle in it that takes an R8 tool holder, or R8 collet. You can fit it up in there. The R8 is a very common size tool holder, and you know, you can get them very easily. They're readily available, they're relatively inexpensive, and you can pretty much get whatever kind of tooling you need for that. This machine, on the other hand, takes a very special tool holder that was designed for this machine and pretty much was only used by this machine. So that makes this tool holder a lot harder to find. To my knowledge, nobody's really making them anymore. This machine, I mean, you know, K&T hasn't made one of these machines in decades. Pretty much been replaced by CNC type machinery in the modern world, which is going to use something like a 40 taper or 30 taper tool holder to go up in there. This, ironically, is a cousin to that style tool holder. I believe this is a 20 taper, but it's modified. It's not a standard 20 taper, maybe a 30 taper. I can't remember, but anyway, with a regular, you know, 30 taper, 20 taper, 40 taper tool holder, there's going to be a drawbar in the end of this that's going to go up into the machine. There's a bolt that goes through there. You tighten that up, and that draws it up into the spindle. Because there's not really the ability to put a drawbar through this, what K&T did is basically they got the same taper, but you take a nose piece up underneath the bottom and tighten it up, and it goes up underneath the bottom of this, and it pulls it up in there and tightens it up in place. And there's a couple of milled out slots in here on the sides that key it in there so it won't spin inside the spindle. But again, this was a K&T design, proprietary, and like I said, just can't hardly find tooling for it. I have the need for some tooling that I can't find, so what do? Well, I have a machine shop. We're going to make them. That's what I'm going to do. So I need 2 custom tool holders built for this. I'm probably going to need more in the future as I use this machine more and more and have some other needs come up. But right now I have 2 immediate needs. One of them is going to be a just basically this taper that's going to come out to a threaded bottom, kind of like this piece here, but instead of this thread, whatever that is, I need it to be 1.5 inches, was that 18, I think? I'll have to look at the spec. But this is for a boring head to screw up on. So I need a custom arbor, a custom tool holder, basically that will mount on the top of my boring head to hold this in place. So that's one of them that I need. The other one that I need is kind of a arbor to mount a cutter on, kind of like a horizontal milling machine cutter. I've actually got this one right here, but the stub coming off of it is too short for the application I need. I need a longer one. I need one exactly like this, just a longer arbor down here on the bottom. So we're going to basically be copying this and making a longer arbor. So that's kind of my job today. I've got my parts kind of sketched out over there, so I've kind of got a drawing to work off on what I need, but I'm going to start doing these. Now, let me kind of tell you my game plan. I'm just going to go ahead and cover it right now. Is we're going to cut some, I got some 2-inch diameter 4140 steel. I've actually got some blueprints from K&T that shows some of these different tools that they had, these tool holders. Not exactly the ones I need, but it shows the detail of the taper and all the specs and whatever. But they basically made these out of 4140 and heat treated them. So that's what I'm going to do. I got some 4140, some 2-inch diameter 4140 that we're going to be machining these out of. I'm going to rough everything out on the lathe. We'll use the taper attachment. This taper is a 3.5-inch per foot taper. We're going to go rough that out on the lathe, and then I will make it just a little bit oversized on all my critical measurements on the spindle here, as well as on this one particular, the arbor down here. We will then heat treat it. And then I'm going to put it over on my grinder, my tool grinder, and we will grind the final taper and the final spindle. I'm going to work between centers so that we can keep everything concentric and everything running true. And anyway, it's going to be an interesting little tool making project, I think. So we're going to get started on that today. I don't know how far we're going to get. I will note that as I get into this, if you follow the channel, you've seen the taper attachment on my Monarch lathe. We tried to fix a little bracket a while back that did not work. Once we started using it, it was actually damaged further than what I had anticipated. There was a hairline crack in there. It broke again. I've got to make a new bracket for that lathe, and just it's going to take me some time to get that done. So to rough these out, I'm going to go out and use the lathe out at the museum that has a taper attachment on it, and we'll just get the taper sent out there. There may not be a lot of video on there because it is, I can film out there. It's just a pain because I've got my camera stuff kind of set up in my shop, and to tear all that down and go out there is not very convenient. So I'll try to get some clips of us doing the taper, but we're going to do most of the work here in my shop. I'm going to go ahead and get it kind of roughed out. Then we'll go out there, we'll cut the tapers, and then finish these things up. So let's get started on these two custom tool holders. So first off here, guys, this is a blueprint that I have, it's actually up on my website, that shows the taper and everything of the working end of this. You can kind of see there's the original. Of course, the end's different. This one happens to be for a Jacobs taper for a chuck, but I'm really more interested in this end down here. And I actually got a couple of drawings. They're all pretty much the same, but I got all the specifications on the taper. Again, that is a 3.5-inch taper per foot, and it's ground. I've got dimensions here to turn it to and then to grind it to, as far as what the dimensions are coming down through there. So I got all the critical information I need to do this. Now the arbors that I need to make these are just sketches, but it's enough for me to work on. These are not to scale or anything. And again, we're going to be making these out of 2-inch stock. It's going to have the same thing down here on the end. This one here is, tell you what, let me just pull this out. This is for an arbor. And it's going to be pretty much identical to this. It's just that this part down here is going to be longer. It's going to be 2.2 inches long, where that's, I think, just 1 inch. But you can kind of see how we got it drawn out. And then the other one is basically, again, it's going to basically be just like this, but instead of having this on the end, it's going to be 1.5 inches, 18 teeth per inch. And then that will screw up onto this boring head to mount it in place. All right, I got my blanks cut out here. The next step is to go over to the lathe, and I want to go ahead and face both ends, get these cut to the proper length, and get the centers put into them. So we will turn these between centers. If you look on these originals, there's a center on both ends, and when the grinding work is done and the lathe work is done, it's done between those two centers. And the nice thing is you can take it out of one machine, go put it in another. It's still running just exactly on the center, and you can flip it around. It's concentric either way you go, so it gives you some flexibility in doing that kind of work. So let's head over to the lathe and get these blanks prepped for doing work between centers. Touch off on that face. Didn't quite clean it up. We'll do a little bit more. Just using a center drill here. We'll go in, and that will cut that 60-degree angle that will fit up on the drive center and the live center and the tailstock for everything to run on. All right, there we go. Let's flip it around and do the other side. Now this side of this particular one is actually going to have a hole drilled and tapped in it, so I'm not going to run my center. I'm going to go ahead and put my hole in there. Going to be tapped half-inch, what is it? Half-inch fine thread, which is half-inch 20. And for half-inch 20, I need to drill a 29/64" hole. Got a 29/64" drill bit here. We can still run this between centers. It's just going to have a larger hole on this side, but no big deal. Do. Now because I am going to run a center on this, I'm going to put a big center drill in here and just put a little bit of that 60-degree angle on there. That'll just give me something for the center to run on, and that'll also give me a lead in for that tapped hole. All right, that end's done. So I've got my drive center on this end. The chuck will actually be turning, and we'll be driving off of one of the jaws here in the chuck. I got a live center on the other end. These will fit up into the center holes on our part. Now in this case, we got the large one. This is the side that's going to be drilled, or it's already been drilled, but it'll be tapped. But we got the center in there. We'll come in, put our center in on this one. All right, we got the drive dog over here driving it on one of the jaws of the chuck. Part is between centers. I mean, it's tight, but it will turn in there. But we got the drive dog on here. This is clamped to the work, and that's hitting the jaw here on the chuck. So that's what's actually going to be driving this. And we turn the lathe on. We are turning between centers. So what I want to do is go ahead and kind of rough out this end down here up to this 2-inch side. This is where the taper will be turned. We're just going to turn it straight, but we're going to turn it to that large diameter, actually a little over that. We'll finish it on the taper, but 1.306. We'll probably go to about 1.325 or something on this diameter. And that needs to go in 2.425. That actually will go from the end all the way into where we go to the large one. I'm gonna have to come in here and cut that little relief in the bottom there. All right, let's come in. I'm gonna start by touching off on the shoulder here. I'm gonna call that 0 on my digital readout. I just zeroed that out. And again, we're going in 2.425. I can just read that right on the DRO. 2.425 is right there. I'm going to put a mark. This gives me a visual indication of where I'm turning to. And yeah, we've got about a little over 600 thousandths. Yeah, 600 thousandths to come off the diameter, roughly. Let's let her cut. face this back side. You can kind of see what we're going after here. This will be all turned down to look kind of like this back here. Now the next step is to cut this groove in here. I've got a parting tool in. I'm going to just try to go in there and carve that out. That inside diameter is nothing critical. It just needs some clearance more than anything else. So let's see what we can do here. I'm going to put my diameter into the digital readout. That'll just kind of give me something to go off of on the depth. I need to go down to 0.875. I'm going to come in until I get on that back shoulder. All right, I'm going to slow my things down here a little bit. Be about 900,000, so I'm gonna go to 1,875. All right, I'm at 1.8 or 0.880. I'm a little oversized, but that's where I want to be at right now, I think. And I want to define that other shoulder. So I want this inside edge to be over, what is that? 2.050. So what I'm going to do is I'm just going to bump this up until it just touches that right there. It's not a super critical measurement. I'm going to zero out my z-axis, and now I can measure over 2.050. Which is right there. And I'm going to go ahead and basically just do the same thing we just did. Should be the same depth as the other one, so now I'm just going to kind of move over a little bit, and we'll just take that other one down. I'm watching the depth on the digital readout. I think we got that done. Come in here and break these corners. And that is ready to go to the taper attachment and cut the taper. Hi guys, I've got my second blank in here. I'm going to do the exact same thing on this one. It's going to not be as long on this end, but the back side that we're working on is going to be identical. I'm not going to show this, I'll just do it off camera, but just letting you know, hey, we're going to do the second one here. I got the short piece done on the other end, and I decided that before we turn the tapers, I'm going to go ahead and turn the back sides of these. I'm set up over here on the lathe, just might as well go ahead and do it. At least get them roughed in. We'll have to grind this one here to final size, but basically just need an arbor on here. It's going to end up being 1.25 inches, 1.250. I'm going to turn it to 1.275, so about 25 thousandths large. Again, that just gives us some material to grind off when we get over to the finishing thing after we do our heat treat. So let me speed the lathe back up. I'll come in and again touch off on this outside edge, zero out my Z-axis. I want to turn this in 2.2 inches. Which is right here. Make a mark, and we'll start turning that in. Again, 100 thousandths per pass. Go ahead and take that down to 2.2, just face that back side. And I'm going to leave it a little bit long as well because I will grind that face to the final size as well. Put a pretty good chamfer down here on the bottom. Break this one, and I'm going to put a little bit more of a chamfer on this back side, I think, just to give it a little transition. I think we're ready to cut our taper on this one. I'm going to get the other one set up. It's got to be a little bit different profile on it. Actually, it's got to be threaded, so let me go ahead and do all that while we're doing the lathe work. Here's our shorter piece. This one will be the one that the boring head will screw up on, and as such I need to turn this down a step on here that's going to be 1.5 inches diameter, 0.475 deep, and that'll be threaded at 18 threads per inch. And because I don't have a way to grind threads, I'm just going to go ahead and machine the threads in there and keep my fingers crossed that after heat treating that everything will thread up like it should. We may have to do a little massaging to make it work, but I think it'll be fine. The nice thing about a boring head is that even if the head's not turning concentric to everything else, it's still going to swing a perfect circle at whatever it's on. So it's going to bore round regardless, even if after heat treating that moves around a little bit. Not worried about it. All right, let's come in here and do this one. I'm going to put a little relief down in the bottom. Come in and first just relieve that front corner at that angle of our lead-in thread. Touch off here. Start with a scratch pass. Confirm we've got 18 threads per inch. It looks right, and it is right. I'm going to think what I'm going to do is I'm going to let this go all the way in. I'm going to let it cut all the way around back in the back because I want to have a little bit of relief in there. And I'll tell you what else I'm going to do. I'm going to slow it down just a little bit more. I was going in there a little bit faster than what I wanted to on that shoulder. I'm going to let it go in. Like I said, I'm going to let it cut all the way around because I want there to be a little gap in the back because I won't have threads going all the way up against the shoulder, obviously. So let's engage. We'll go to the shoulder, stop, and I'll just let it cut all the way around, and I'll come back out. And we'll make another pass. There, I'm going to make a much lighter cut this time. We're getting close to being where we need to be. And I'm going to do a test fit. All right, I got to take this out of the lathe to do my test fit, but assuming we have to put it back in and make another cut, it's very important that we time this dog to the same spot. So I put an X mark on this jaw so I know this is where it comes back in, because we'll probably have to put it back in. Let me go ahead and take it out. And it's starting up on there, but it's too tight, so we do need to make another pass. So we'll put it back in and cut just a little bit more. Back down to my 0. I'm going to give it about another 3 or 4 thousandths. We'll wait for a number to come around on the thread dial. And here we go. All right, let's do another test fit. And let's try it in here now. Get that thing to line up. That is screwing up on there just fine. Up against the shoulder. That's exactly what I want. All right. That is done. I am going to put it back in the lathe, and we'll leave a couple of edges on this. But I got that done. Just going to leave that edge a little bit, put a nice little chamfer on it, and also put a pretty heavy one on the back here. We'll grind that outside diameter when we get it on the grinder, just to make it run true more than anything else. Well, our tool holders here are starting to take shape. So next, and again, it's probably not going to be on video just because of camera situation, but I'm going to go turn the tapers, rough the tapers in. I'm going to leave them a little bit on the large size. And then once we do that, we'll bring it back in. We will heat treat these, harden them, and then put them on the grinder to finish them all up. So I'm going to take these out and get those tapers roughed in. And we'll be back. I'll probably show you that when we get back. And if I swear I can, I may just get a couple little clips of us doing that while we're out there with my phone or something like that. But these are ready to go to the museum and cut the tapers. All right, we've got the first one of the tool holders in here, and I'm starting to cut that taper. So we're just going to kind of start it out, and basically I just need to cut that taper until it kind of comes out on the back end. So that's my first cut. And go back out here. I'm just going to do about a 40 thousandths cut, take my time on this. Let it slip, ease back in there. Make our next cut. I had this set up when I cut my test manual a while ago, and according to my taper micrometer, we were in about 1/1000th of an inch per foot of being dead nuts on. And like I said, I wasn't going to fool with trying to fiddle it and get it just perfect, because we're going to be doing that over on the grinder later on. I just want to get it real close and real get it set up perfectly over on the grinder when we grind it in. Anyway, you can kind of see the process here just a little bit at a time. I'm going to continue on here until we get this turned out. All right, I'll bring you back when we're done.